Okay, good afternoon, all of you. Am I audible? Sushil Soden. Am I audible, Sushil? Am I audible, Sushil? Your voice is not coming from my ear. Okay, so let's start. So we have discussed in our previous classes, that is the Z transform. So in this Z transform, we have to discuss various types of properties. Okay, and some of theorem we have to discuss in previously. So that means final value theorem of Z transform. Okay, and also discuss initial value theorem and also complex translation theorem. So these are the basically different theorem we have discussed in previous classes, that is Z transform method. Okay, so using this final value theorem and initial value theorem and translation Z transform, we have to classify different discrete time signals in our advanced control systems also. Okay, so today we will discuss one mathematical problem or examples from the final value theorem. Okay, so I am sharing my whiteboard. My whiteboard is visible, everyone? Please respond me. My whiteboard is visible, everyone?
Yes, sir.
Okay, thank you, thank you. Okay, so first examples from the final value theorem. So everyone please note down in your exercise book. This is we have practices different problems. So this problem is very much important for your semester exams. Okay. So problem on final value theorem. And we have discussed in the previously final value theorem. This is basically two variables, that is we have to express here xk and another one is the xkt. Okay, so where xk is the 0, that means that is the xk is equal to 0 for k less than is 0. It is the Z transform of xz, we know that. So we can write the final value theorem, that is also limit k tends to infinity xk, this is equals to limit z tends to 1, that is 1 minus z inverse into x of j. Okay, so this is the basically mathematical form of our final value theorem we have discussed in our previous classes. Now using this theorem, we have to solve in our different example in our discrete control system. So now we have given examples. Question is, determine the final value that is x of infinity of function is xz equals to 1 by 1 minus z inverse minus 1 by 1 minus e to the power at into Z inverse, where A is greater than 0. Okay. So this type of problems is coming in your semester exams. So determine the final value of the x of infinite of the following functions. So these are the basically following functions of the Z transform. Okay, where the value of A, it is also greater than 0. So now what have to do? You have to apply the final value theorem into this problem. Okay, so by using the final value theorem, we apply, that is x of infinite, that is equals to, you know, the mathematical expression of the final value theorem, limit z tends to 1, that is the function 1 minus z inverse into xz. You know this mathematical expression from the final value theorem. Now you have to put, that is the limit z tends to 1. These are the basically same, 1 minus z inverse into, you have to put the value of xj. What is the xj? These are the basically xj. Okay, so 1 by 1 minus z inverse minus 1 by 1 minus e to the power at z inverse. Okay, so this is the basically functions of the final value theorem. We have applied the final value theorem into this function. Now you have to, sorry, you have to solve these equations. So here you can see, you have to multiply this 1 minus z inverse into this part and also into this part. What I have to do? So this and this is basically cutting down. These are the same thing. So the here the rest of the part, that is a 1, then minus of this multiplied by this. So the function is coming, 1 minute. Limit z tends to infinity function is coming, limit z tends to 1 just wait. Just wait. Okay, limit z tends to 1. So you have to multiply this term to the this term. That is 1 minus 1 minus z inverse divided by 1 minus e to the power at into z inverse. Just wait. So my whiteboard is visible, everyone.
Yes, sir.
Okay, so I am just written again. That is x of infinite. That is the limit z tends to 1. To know that the final value theorem, these are the basically mathematical form of final value theorem. That is 1 minus z inverse into x of z. Okay. So now these are the same thing. Limit z tends to 1. That is 1 minus z inverse, and the value of xz, you know that from the given questions, this is 1 by 1 minus z inverse minus 1 by 1 minus e to the power at into z inverse. So you can easily put these equations also. Now you have to calculate. This is basically 1 minus z inverse multiplied this and this part also. So the equation is coming, that is limit z tends to 1. This one multiplied by this one. This one is cut. That is the 1 minus, next part, 1 minus z inverse divided by 1 minus a to the power 80 z inverse. Okay, this is very much easy purpose. You have to put the value of z. This is the z tends to that is the 1. So you have to put the value of z, that is 1. So again, this is the basically 1. Okay, the answer is coming to know that this is the 1. That is 1. So it is noted that this given the value of xj, it is basically answer is coming, that is the infinite range, that is also 1. So we have to written that is x of t, this is equals to 1 minus e to the power 80. So this is the xt, we can easily write xt, this is equals to 1 minus the whiteboard is again and again disturbing. One minus e to the power minus of 80. That means when you have to put this t is equal to infinite range, so that means the value of is coming from here, that is the 1. So this is the basically a result of the given problem using the final value 0. Okay. Next, in your syllabus, another topic is present, that is the inverse Laplace transform. Okay. So in inverse Laplace transform, we have to apply different method. So first, inverse Laplace transform. Sorry, these are the inverse Z transform. Sorry, because this Laplace transform we have to learn in the previous control system. So inverse Z transform. Inverse Z transform. These are the same thing, but sign it is also changes. Okay, I am written here. So first of all, you have to know what is the inverse Z transform method. So when you have to retain the Z transform, that is function is x of z, yeah, something like that. And when the inverse Z transform you have to retain, this is basically Z inverse. Okay, so this inverse of Z transform the inverse of Z transform of xz with corresponding time sequence, that is also x of k. Okay, so the true function is coming previously, that is when x of z, the z transform of x of kt, or another one is also x of k, is given the operation that determines the corresponding, that is x of kt, or sorry, x of k is called is called the Z transform. Is called inverse Z transform. Okay, so this is the basic definition of the inverse Z transform method. So in our mathematical expressions, we have to express the Z transform method into the Z inverse. So now xz, this is the basically Z transform of function of either x kt or xk. You know that x of kt means k is the value of, that is k is the value of, that is 0, 1, 2 dot dot dot. So this is the basically value of the k, you know that. So now the value is changes, that is k is changes, the value is also changes, that is x of 1t, x of 2t, 3t, 4t and so on. And these are the same thing, x of k, k is the value of 0, 1, 2, 3 dot dot. So these are the variations, it is coming into the corresponding of the x of kt or xk. It is basically called the inverse Z transform method. So when you have to solve the different value, that means you know that k is 0, 1, 2, 3 dot 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 dot. So the time lapse, time it is also basically changes, you know that, that is a sampling time. So time is basically 0, t, 2t, 3t and so on. Okay. Next day I am changing my yeah, whiteboard also. Okay, so this whiteboard is slightly disturbing again and again. And PPT prepare one PPT slide show also. Because this is very much disturbing. That is t is equal to 0. You know that. That is the t, 2t, 3t, and so on. Okay. So this is basically called the inverse Z transform method. So in our discrete control system, this inverse Z transform method, we have to solve in 4 categories or 4 types of methods. Okay. So basically, we have to use as defined methods. Of inverse Z transform. Number 1, direct division method. Number 2, computational method. Computational method. Number 3, partial fraction expansion method. And number 4, inverse integral method. So these 4 types of method we have to use is calculation of the inverse Laplace, inverse Z transform method. Direct division method, computational method, okay, the partial fraction of expansion method, and inverse integral. So when the obtained in the inverse Z transform method, we have to assume that is x of kt or xk. This is basically when k is less than 0. Less than 0, that means fraction part, that is 0.5, 0.25, etc. So these are the basically ranges of the inverse Z transform method. Now you have to know poles and zero. To know the previous control system, what is pole and what is zero. Okay, so these poles and zero we have to consider from here, that is Z plane, that is a Z transform. Okay, next. Next, that is a poles and zero. Poles and zeros in the Z plane. This is one of the important topics. Okay, poles and zero of the mapping of S plane or Z plane. That is a zero, poles and zero in the Z transform. So in our control system, that means advanced control system, and also digital signal processing. We know that DSP. This digital signal processing and advanced control system, we have to consider this type of inverse Laplace transform method for the calculation of poles and zero. So now we have to express, this is the functions, you know that xz, this is equal to a b0 into z to the power m plus b1 z to the power m minus 1 plus dot 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 plus bl divided by, that is z to the power n plus a1 z to the power n minus 1 plus dot 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 plus a. Condition is here m is less than equal to n. Okay, so this is the basically poles and zeros functions or expression for the Z transform plane or Z plane. Okay, so please remember these things also. So now we have to express these equations, that is xz, this is equal to b0 into z minus z1 into z minus z2 dot 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 dot. These are basically same thing in the previous one, that is z minus z2 divided by, this is same thing, that is z minus p1 into z minus p2 dot 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 z minus p. Okay, so you know that these are the p for basically uses for the pole, and z, this z1 z2 zm, that is the m number of zero functions. Okay, and this p1 p2 p3 dot dot pn, these are the basically poles. Okay, is it clear all of you? Where the pi, pi means, that is the, here I is equal to 1, 2, 3 dot 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 n number of times. Okay, and this is basically for the, sorry, one. So this I is the 0, 1, 2, 3 dot dot n. This is are the poles of function is xz. You know that, and another one is z, that is the p1 pi, sorry, p1 p2 at dot 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 dot, that is pn. Another one is the z1 z2 zm. These are the basically different zero function, that is the z s, that is here j is the basically zero of the functions. That means here the previous one, that is here j is equal to, that is the 1, 2, 3 dot 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 m number of the zeros of xz. Okay, so now we have to express these equations. This is x of j. This is equal to b0. Everyone write your own name and roll number in the chat box. Pranab is present. Response me. Pranab is present. Pranab is not present. Okay. So Milin is present. Milin. Milin.
Yes, sir. Yes, sir.
You take a screenshot of the participant list, and after ending the class, you have to send it. And everyone write your own name and roll number in the chat box also. So that is B1 Z of minus N minus M minus 1 plus dot dot dot. This is continue. That is Bm Z to the power minus M divided by, that is 1 plus A1 Z inverse plus A2 Z inverse 2 plus dot 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 plus AN Z inverse Z to the power 4. Any question, anyone? So otherwise mute yourself. Okay, so this is the basically functions of the poles and geos. You know that. So in our digital signal processing and also control engineering, we have to use these xz functions for the pole geo calculations of the polynomials of the z areas. Okay, so when you have to solve the different problem, so this idea is very much clear of that. Okay, now we have to given one example. Which one? Milin? Any questions, Milin, or otherwise you mute yourself? Okay. Okay. So, example. You have to given one function, that is xz is equal to z square plus 0.5z divided by z square plus 3z plus 2. Okay, so you have to given these equations. Now the common part is part here, that is z. So z is common. The rest of the part z plus 0.5, and you have to solve this middle term factor. So you know that everyone, middle term factor is factor you have to solve, that is z plus 1, another one z plus 2. You have to multiply z plus 1 to the z plus 2, the function is coming z square plus 3z plus 2. So here basically in this function xj, the poles are, you know that is z